And I have the pleasure to welcome you all to today's webinar, Revit 2026 Key Features in Practice. So, my name is Per Ole Otternes. I will be your host. I'm based in Oslo in Norway. I will not be doing so much talking because that's what Lawrence and Paul are going to do. Lawrence as the Revit structure expert and Paul the expert on Revit core and Revit architecture. So you guys will be doing most of the talking, but I will give you a short introduction. We will present what Paul and Lawrence finds as the greatest highlights of Revit 2026. So this is your opinion, and I think that's great because I want to hear what you guys like, not what someone in the US likes. There is a question button down in the right corner. Please use that to ask questions. We will answer live on the fly, and if there are someone who's asking very difficult questions, we must take the liberty to come back to you, and we will do that. So please don't hesitate, ask questions. I have a small tip in regards of the resolution. You have a button down in the middle which says display. Use that to do the full screen. It will give you a little bit better resolution, so you can see what Paul and Lawrence are going to show you in a better way. The webinar will be recorded. We will publish the recording maybe this week, probably next week, and you will receive an email when that has been done. So please share, please re-see it if there's something that you would like a recap on, and share it with your colleagues. And the last thing before we kick off is we have a question for you, which is, we would like to know which version of Revit you currently are using. And you may answer more than just one version. So please let us know what you are using at the moment. Well, the poll says that it's after 250 plus votes, about 37% on 2024, 35% on 2025. Some of you actually installed and are using Revit 2026 already. Great. And then we have about 25% using 23 version or older. So it's quite well spread around versions. Okay, that's my 4 minutes of fame. I would like to hand over to you guys. Lawrence, I think you will up first.
Yeah, thanks very much, Per. So I shall share my screen and we'll get going. Okay, so let's begin with our big ticket item. So I think if we look at all of the new releases for the last decade, really, on the structural front, we've had either major improvements to rebar or steel detailing or analytical modeling. So I'm going to begin here with our reinforcement tools. And the first thing, which I think is really, really good, is rebar cranking. So this is very, very popular if you're joining columns together. So if you're splicing columns, so you've got bottom column and you want to put the top column in. That's also good for piling as well, or you can use it for beams. And much like rebar splices that were introduced in the previous release, these are type families and we can have multiple types configured. Also, we have a whole bunch of built-in parameters that are available to allow us to actually control these splices and, more importantly, create the proper bending schedules. So you can see on the image at the moment, we have a bending schedule there. And of course, both in the UK and the Nordics and other countries, we want to make sure that it's got the correct shape code, as well as all of the correct dimensions, of course, in the bending schedule. So I'm going to now demonstrate this live in the software. So just switched across into Revit 2026, of course, and you can see that we've got a couple of columns already set up in here. And if I select the bottom column here, you can see we have the rebars coming through. This is obviously a circular column here. This is being done with freeform rebar. For those of you that might be asking how we've done that, there's a cage. And what we're going to do is we're going to now apply a rebar splice to this. So let's begin by finding our system family. So in the project browser, we'll simply just type in the word crank in here. So if we do that, we can see that we've now found our system family. And I have one type in here, but of course you could duplicate this and make new ones if you wanted. And we'll just begin by reviewing the type properties here. So notice we have a crank slope 1 to 12. Okay, that's pretty standard for a column crank. You can see we have an offset multiplier. So that simply means that we've got 2 times the bar diameter. So the bar at the top will slide in nicely to the cranking rebar. And we have a lap, if you like, or a length multiplier for 45 times diameter. So with that then done, we can now look at how we would apply that. So if I select the bottom rebars here, another new feature that we'll kind of investigate a bit later, but I want to highlight to you now, is that we can very easily now see the start and the end of the rebar set. So you'll notice we have these in-canvas graphics. If I just pause my cursor over it, we have start of bar, end of bar. In the properties palette, now you can see that I can go to start of bar. And of course, as we know here, we could apply an end treatment or a hook. And now we can apply a crank in here. Doing that, you can see that we then have our crank type that we're applying. So in this case, I've got my 1 to 25, and we can now see that rebar crank directly in canvas here. Let's now do a similar thing to the column on the right-hand side. So here I've got multiple rebar sets for this rectangular column. So I'll begin by selecting the rebar. We'll obviously filter out the column because we're only interested in the rebar, of course. Now that we've done that, again, we can go to our start of bar and we can go and locate our crank again that we want to apply. And here it is. You can now see we have all of that bar cranked. Now, to help us see this a bit better, what I'll do is I'll select all of the rebar inside that. And what we'll do here is we'll just make sure that we can actually visualize that. So we'll go to the view visibility states, and I can see here I am in fact viewing that unobscured. Now let's just take a look at some other settings in here. So I'm just going to switch into the south elevation. Okay, and straight away here, if I zoom up, you can see that we can now preview our rebar cranks. Now, what's quite handy with this, if I actually go here to edit constraints, you can see that we can actually constrain the knuckles here, okay? So basically what that means is I can actually pick on this knuckle, which is the bottom part of the crank here, and then I can set a dimension that I want to place this in. And you can see we can very accurately control exactly where the crank goes, so where it starts and ends. And I can do the same at the top here. So for example, I could put in 0, you can now see I've got the actual start of the crank just on the rebar cover there. And of course, then we've got the lovely straight lap coming up to lap in with the bar at the top. So that is incredibly useful. If we also now finish that code constraint there, and we go into the type properties of the rebar, what we can see here is we have splice lengths, crank lengths, and hook lengths. And if I go into the crank length in here, we can see this currently has an auto calculation, but what's really good with this is I can just remove the auto calculation and then start to override any of those dimensions that I want. Okay, so that's very handy. Okay, so we'll investigate some of the built-in parameters a bit later on here, but let's now move into the next part inside here. So we're going to just now go to the next new feature, which is varying rebar. So we've had varying rebar in the software for a long time now, of course. What was the issue in older versions is if you look at the bending schedule at the top in here, you can see that I've got 2 rebar sets that are varying. They are identical bars, so they've simply been mirrored. So looking at bar mark 1A, you can see we've got a length of 550, and I've got exactly the same for bar mark 02A. Now, of course, in reality, that would want to be just a single set of bars there with 2 of them. So what we have now is a new setting under reinforcement settings where we can match the shapes of identical bars. So once again, let's look at this in the software itself. So we'll switch back to our 3D view and we'll just inspect the situation we have here. So we have a varying rebar set on the left-hand side and obviously exactly the same mirrored rebar set on the right-hand side. So let's begin by looking at that bending schedule. Okay, so just jumping into the bending schedule, I'll zoom up on this so you can see it a bit better. You can see here that in fact we do have those duplications which we used to have in previous releases. What we can now do is select the structure tab, then we can go to the reinforcement slide out, and here we can go into reinforcement settings. Inside the settings now for varying rebar, you can see that we in fact now have the ability here to match sets with identical bars. And clicking OK, you can now see that Revit has now counted up 2 bars for each of those elements. So nicely done. Okay, brilliant. So what we'll now do is we'll switch into the next part. So here we're just looking at some generalized rebar enhancements, and there's some really good stuff here. So the first thing I'm going to draw your attention to is this shape name, which is a new built-in parameter for all rebar shapes. So previously, the rebar family actually dictated the shape code. But what I can now do is have many different rebar shape families with individual shape names. So it means, for example, for a cranked bar, it could just be rebar shape 1, rebar shape 2, but it will schedule as a 26. Looking at the middle part of the screen here, you can see that we have fabric reinforcements being displayed here. And what's happening here is we can now orientate the wires of cover. We can either have the major or the minor direction at the bottom of cover. And finally, we've already kind of talked about this, we can see the start and the end of bar. So again, let's go back into the software itself and we'll take a look at some of these features. So I'll select this L bar over here, and this is quite nice. You can see, again, very easy to see where the start and the end of the bar is. So, you know, if we're adding couplers or end treatments or cranks, as we've just described here, we know which end to apply that to. Let's now take a look at the crank bar. And what we'll do here is we'll edit the family. So selecting that cranked bar, if we go to edit family, that will obviously open up in a new window. Okay. What you will notice here is that the family name is rebar shape 2. If I go into the family types over here, we'll now see that we have this new built-in parameter called shape name. So I've just highlighted it here. And of course, that's shape code 26. So that's how it's going to schedule. More importantly, looking down through the built-in parameters, you can see that we've got several new parameters for the start crank and the end crank. And of course, that enables us to then be able to calculate the precise length of that cranked rebar utilizing these built-in parameters. So that's a really key kind of function there. Okay, so we'll just close the family down. Okay, and we'll just go into the next slide. So we're going to move out of the rebar detailing now, and continuing with Autodesk's steel detailing journey, we can now enable what we call point-to-point steel modeling. This allows the user to accurately create steel elements without those cutbacks being applied. So looking at the image on screen here, you can see that the vertical and diagonal web braces on this truss are cut back, and Revit would just do that automatically, and that could be a little bit difficult to be able to control the exact length of these shapes. So we can then apply this point-to-point modeling, and it gets rid of those automatic cutbacks. So once again, we'll take a look at this in the software itself. So you can see here we have the truss in here. And as we've already explained, and as you would already know, we have automatic cutbacks applied to all the steelwork in here. So if we want to now get rid of that and have point-to-point modeling, we can go to our structure tab over here. We can go into the structural settings, and looking into the structural settings dialog on the far right-hand side, we now have structural steel elements. And here, very simple tick, we can disable the automatic shortenings. We're informed that this is going to do this for the entire project. We can just accept that there. And when we click OK, you can now see all of those cutbacks and springbacks have been removed. So looking into this, if I now start to do some additional modeling in here, we'll go and enable 3D snapping in this case over here. And then what you'll now notice is as we start to kind of model inside here, what's going to happen is all of these elements that I start to configure in here will have absolutely no cutback at all. So if I just create a bit of a diagonal on the end of this over here, we can see there's no cutbacks or springbacks being shown at all. Okay. So moving into the next feature over here. What we're going to do now is look at accurate steel weights. So we've had the ability to calculate steel weights for a little while now, but the issue with it is the steel weights only showed up if we put structural connections on. That's now not the case. We can get the weight, the exact weight in the paint area from any steel member. Once again, let's look at this in the canvas in the software. So if we come along here and we select one of these steel members over here, looking into the properties, okay, just in here where my cursor is, I can now see I have a weight, an exact weight, and a paint area. Now you'll notice there's a slight discrepancy between the weight and the exact weight, and that's how the calculation's being performed. So the exact weight will take into account structural openings and all sorts of things that we put on steel elements. So just to show you this, you can see I've just got a normal steel beam here. Take a note of the weight. You can see it's 44.48 in there. What I'm going to now do is go to the structure tab, and I'm not going to use one of these steel modeling tools. I'm actually going to just create an opening by face in here. So we'll select the correct work plane. We'll create an opening through this. And there's the opening. And now looking at the weight, you can see the exact weight is now 42.71. Okay, the weight is now not taking into account that structural opening. If I delete the structural opening and select the member again, you can see we're back to 44.48. So that's a big step forward. Something I do want to draw your attention to, though, which is going to be really important for you, is you can see here I do have a paint area. And if you've tried this before in 2026, you probably won't see a paint area there. And that's because a lot of the Autodesk families don't actually have the perimeter applied. So again, if I edit the family, so I can show you how I've calculated this. This is a UK universal beam, but it will be the same for any other European shape. We can go into the family types over here, and you'll notice I have a perimeter. And generally with the Autodesk out-of-the-box families, this is generally 0, empty. So you can see here I've applied a formula to allow me to calculate out the exact perimeter of that, and that's what's used for the paint area. Okay, we'll just close out of that family. And the last thing I want to just draw your attention to here is if you now look under dimensions, you've got a cut length and you've got a system length. So Autodesk have rebranded and renamed this, and a system length is now what used to be length in the older software versions. And I think this better describes what's happening with steelwork. So the cut length is cut, the system length is the point-to-point length. Okay, great. Okay, so what we're going to do now is look at custom steel connection editing. Now, this is quite a big step forward, and this is best for me to just show you this directly in the canvas itself. So we'll just switch into another project here, and you can see that I have a portal frame detailed here. And of course, we have all of our steel connections applied to all the steel elements inside here. Zooming into the haunch connection over here, you can see that I've actually started to model some additional plates, bolts, and elements. This is going to be to actually take a member that's going to go across all of the columns here. So what I really want to do is now just complete this modeling. So I'll go to the steel tab. I'm going to first create a plate in here. We'll pick a plane. So just pick on the front of this. And in this example, I'm going to use a polygon to enable me to create a square plate. It's just easier. So we'll have 4 sides in here. And of course, I want to now snap to the center of the tube in here. So we'll get that done. Let's make sure I've got 4 in there. Okay, and we'll snap in there. Okay, so we want 75. That gives me a 150 millimeter plate. There's the plate created. So we'll just make that 12 millimeters. Something you will notice now also, the plate has a default material applied. So I don't no longer have to do that for every single plate that I create. We'll now create some holes. So we'll go into holes, we'll pick on the front of the plate over here. Once again, we'll use a rectangle so we can define 4 holes quite quickly. As you probably know here, those holes will be created on the corners, but of course we can then go through and refine that setup in here. So I'm going to go for perhaps 100 millimeters inside there. Okay, we can see now we've got a slightly better arrangement, and we'll just change the diameter to 14. So that'll be for an M12 bolt with a 2 mil clearance. Okay, so there's my custom connection. So what I'm going to do now is select the standard connection up over here, and you'll notice I can go ahead and customize this. So doing this, we can give this a name. I'll just leave the default for the moment. And you can see now we can now add and remove elements into the connection. So I'm going to go to add here and select those elements that I've just modeled. Okay, so you can see now they've been added in, and we can just finish. So now that's going to be added in, okay, and that's now a custom connection. So of course, what we can then do is we can select additional connections like this, and then apply that custom connection that we've just created in there. So looking down through this, I should better see my custom connection in here. There it is. And if I just select that and apply it, obviously this is now generating out in the background. Okay, and we can now see that custom connection applied. What's really cool with this is if I now select the custom connection and I edit it, let me just make some design changes here. So I'm going to go to the plate, and I'm just going to extend the plate's length, like so. Okay, we'll let that calculate out, and then what we'll do is we'll select the actual holes themselves in here, and perhaps we'll ask for 3 holes. So, okay. If I now finish that, you can see that Revit informs us that all instances of this custom connection will be updated. So of course, as you would probably second guess now, that's going to go through and make sure that all those other custom connections are now synchronized to that change. So that's a huge step forward for that steel detailing. Okay, so we're going to now move away from structure, and I'm going to start to now look at some of our core features in here. Now to do this, I'm just going to switch into another project, okay, just so we've got something else to look at here. Okay, so this is one of our sample projects that we're probably all used to now. And what I'd like to do is just jump into a furniture layout in this example, okay, and I'm just going to select one of these tables. Okay, so what we're going to do here, if I just jump back into the PowerPoint first here, you can see that we have modernized user interface. So what we're trying to do here is move as much as we can off of the options bar and start to put it onto the context tabs. So you can see we've got this option here for rotate. It remembers whether you use place or center, so you're not constantly going back and having to toggle between those on the options bar. We've got the same thing for our wall joints in here, so the wall corner joints, and the same thing for array. So you'll see this in a number of areas now, and it's a journey that Autodesk are on, as I say, to try and get rid of that options bar. So let's go back into the canvas here and into the software, and we'll take a look at how this all works. So if I now go to rotate in here, if I want to rotate this, notice that the place option is now default. You can see up here, copy's already on, so very easily take that off. I can just place my point wherever I want this to rotate and then rotate that round. If I go to the next one over here and I want to rotate again, obviously I can repeat the command. And this time I can obviously now pick a different center point to rotate without having to start messing around picking all of those options that we'd normally do on that options bar. Same thing with copy. If I go to copy, you can see I've got my constraint option and multiple up there, which is very useful. If I go into the array tool over here, again, we've got all of our functionality for linear and radial arrays and so forth. Last thing I'll show you would be on one of these wall corners. So if I select one of the walls over here, what we'll do is we'll go into our wall corner join, select the wall corner, and again you can see the options bar is nice and clean now, and everything is up on the context tab. A lot easier for new users to actually understand what they're looking at there. Okay, so this one I'm just going to rely on a little video for. So this is the accelerated graphics technical preview. Okay, and what we'll do is we'll look at how a project would normally respond without a technical preview. Without the graphics accelerator. So you can see there's quite a busy project here, and this is without using the accelerated graphics, and you can see the graphics popping in and out. It's very joggy, not very smooth at all. A lot of things are just not able to be displayed. This is the same model using the walkthrough now with the accelerated graphics on. So this is making use of your graphics card. It's a more modernized approach of working. There are some limitations. It doesn't work with point clouds, also switches off shadows and things like that. But it is a tech preview, so it's definitely worth looking at. Okay, so moving on to the next feature, and I think this is quite a big feature really. When we link IFC files into Revit, we've never really had a good way of being able to place it out in a certain location. But you can see here that we've now got three options. We can go origin to survey point, origin to project base point, or origin to internal origin. We can also control the rotation as well, whether we orient to true north or not. So that will be a welcome addition for anyone using IFCs. Another option here is on manage links. This is quite useful. So this allows us to actually locate an imported CAD file and actually then be able to show that in the canvas. And I'd like to just show you this in the software itself. So if I go to the Insert tab and I select Manage Links, notice now it's changed position. It's right at the start of the ribbon to make it easier for us to see. We can now see we have this imported DWG file inside here. Nice and simple. If I right mouse on this, I can show it. I can then ask Revit to open a view of that. And there's that imported CAD file. If I triple click down in here, we can then copy that path to the clipboard and then go and locate where that actually resides. So that's all part of the ongoing work on this Manage Links dialog. Okay. And finally in here, before I hand over to my colleague Paul, we're just going to have a little conversation around topo solids, and Paul will continue this shortly. But one of the things is, for architectural modelling, the topo solids is much quicker, much easier for architects to use. But for those of us that want to use this on an engineering context, for example, taking tin surfaces from Civil 3D into Revit, there's been some major issues. So there was a point limit of 10,000 points. That's now been changed, and you can change this in the INI file. You can set this up to a maximum of 50,000 points. And in here, you can see mine's currently set to 30,000, and this does increase the accuracy and resolution of your topo solid. I will say it's an improvement, but there are still some issues with this. Okay, it's still not perfect, but it's better. Okay, so thank you, and I shall now hand over to my colleague Paul.
Thanks, Lawrence. I'll share my screen. So yes, we're going to look at some of the modelling around the topo solids, and there has been sort of continued improvement actually since they was introduced in 24, which I think anyone that's used them back then, I think it was a bit disappointing, but they've been refining it and making it better and adding new features as we go through. In 2026, we've got a few sort of significant bits. So the first one is the subdivision type. So up until now, we had to create the subdivision and then assign an actual material to it. Well, 26, we can actually use other topo solids as the subdivision. And that's actually made a real good improvement. But along with this, we can also have either a zero offset, so we can keep them flush with the existing topo solid, or we can also now put in negative values. So it's made it a lot better actually. And we'll have a quick look at this. There's one more feature we'll mention, which is really just a kind of performance one, which is the cut void stability. So let's just jump into Revit and see this. So now when we select the topo solid, we've obviously got the subdivide option, so this hasn't really changed as such. But what we're looking at now is we're actually choosing from our other topo solid types to create that subdivision from. So very simple to do. We'll just keep it quite easy in here. We'll just draw a circle in. And then that's created as a subdivision. Looking back at the properties here, we can see it's got a zero offset. So, you know, that's an improvement straight away, but now we can also put in that sort of negative offset and have it sink down into the surface here, which is that sort of improvement. And I think when it comes to modeling sort of more urban sort of roads and things like that, then using the subdivisions and being able to actually sort of create topo solids with those, it's going to make it a lot easier. So these are created with using subdivisions here. Just one little thing, we spoke about the actual cut void stability. So that's when we expand out the model site property here, we have the cut void stability option. And really it's just a checkbox, so it's off by default. I've enabled it in this model here, and it kind of changes and makes some shifts to the sort of nodes and points and things, as it says in here, just to give us, it's not 100%, but it gives us much greater accuracy or reliability when it cuts. And what basically happens I get it most when we try and put in something like a path that aligns to the edge of another topo solid, it will go through and it will just give you a warning here. So looking at this, the warning is just saying that the cut stability has been applied, and for the exact values, the amount it's sort of changed the geometry is actually recorded within the journal file. So you know, if it's very critical that we know exactly what's going on, then we can go and investigate that in the journal file. But in general terms, it makes it much easier for modeling roads and paths, and it just means that, you know, rather than have lots of separate objects, now we can quite easily come in and just make changes to this road here, and we kind of know that because these are subdivisions, the paths are going to follow it along. So, you know, I think that's actually quite a good improvement in here. And with the negative subdivisions and using the topo solids, and then also you know, the excavate option that they brought in 25, I think the topo solids have come on a long way actually, and are now starting to become very usable, a good sort of landscape modeling tool. So we'll swap back, and then the next part we was going to have a look at was really around the sort of walls there. So in 25, we had the auto join and the auto join and lock introduced, and that's quite good for modeling finishes. We've had an extra couple of features added to this in 26, and we can see there we have place by room and place by segment, and these now work by allowing you to just select inside of a room or select the segment of wall that's bounding a room, and then it would just create the walls along there, and then we can combine that with the auto join and lock, and then it's you know, it's for modeling finishes is what it's really aimed at, but it becomes a much quicker way of doing that actually. We've also got a few little updates in the way the wall types are built, but it applies to floors and topo solids and roofs as well. So let's just jump into Revit, so we can jump into this one here. So when we go to place a wall in, assuming we're in a 2D view, in a plan view where we can see the room, then we have the place by room and the place by segment option enabled. But just before we do that, if I come and look at the wall type that we have here and look at the structure, well, we can see firstly in 26 we don't have to have layers inside the core boundary. So when we're making things like finishes here, we can just have it outside of the core boundary as it is just a finish. We don't need to make it structural, and this is going to make it easier for us to control how it joins and interacts with other objects. And then the second option in here is that the function and the priority are now separate, so that we can keep the function. You know, there was at times where we would have to set a structural object to be substrate or a thermal air layer to be structural, so that we can get the correct priority value for when the objects are joining. Whereas we've now got that separated out, and that's going to give us a lot more flexibility. And this applies to all of the object types that use this kind of interface. So say walls, floors, roofs, topo solids, they all inherited this function. So coming back to our walls in here, we can do the place by room. Looking at properties here, I've just got this wall, it's unconnected, it's just going to be 1200 high. I can put the auto join and lock on as well. And then when we come over to the room, we can see it highlight the boundary of the room, and just within a single click, it just goes and adds all of those in. So it's just a nice quick way of running around that just there. If I undo that back and we do it by segment, then as we come in closer, we can see it's just picking up the individual sort of lines within the walls here, which is then going to give us a bit more flexibility to change settings and apply this to different walls with different settings on. And yeah, it's just going to be a nice quick way of actually modeling these finishes live within Revit now. So again, small improvements really, but I think if you need to actually physically model the finishes, which we're seeing more and more people doing actually, then that's going to make it a lot quicker. I've also tested it with linked walls. So if you link your model in, you need to create the room in the live model, but you can have the linked model as wall bound in. Then this functionality also works with the segments as well. So there's a kind of nice bit of help there for when we're working with linked files. Okay. Now coming on to some of the more sort of core features here. One thing with inside of families, we're probably used to seeing the Omni class number, which has been there, what feels like forever. And that's obviously a US standard. We've never really used it in the UK, and I assume that probably not in the wider European context as well. But for 26, they've just renamed it to classification number. So it's a bit more generic for us. When you go in to actually select it, there's an option to open up the file or open the location of the file, so we can find it easier and actually then customize it to suit our own sort of local standards that we want to use. So I've just created this uniclass document here that we can use, and then that's made it a little bit easier for us, I think, to make use of that parameter, which we all just ignored until now. And then the coordination models from Autodesk Docs, so again, they're fairly new. They've been a nice way of being able to get different model types into Revit and keep it quick. Actually also being able to link in different versions of Revit and see those inside. But 26, we've got a few more controls, so we are able now to in the visibility graphics expand out and see all of the categories in there. We can control their visibility. We can also apply some overrides to the colors and things. We can also, in the actual canvas itself, if we tab through to select one of the objects in the coordination model, we can actually hide it by element, which means that if we need to replace something because we're doing more detail, creating more detail over the top of it, we can coordinate with it, but then hide it out as well when we need to. And also via the managed links, so Lawrence showed a little bit around DWGs, the coordination models are in there, and we can also use the show option to go find where they are in our project as well. And then coming into the sheets and views, so there's been a few tweaks around here, and one very big one that we're going to have a look at. So firstly, I was quite excited by this initially, if I'm honest. But then was less so once I explored it a little bit more, but I think it's still worth mentioning. So each title block, when you're in a project, if you click on a title block family and click edit type, you'll see it has a parameter for scale override. And this is basically when we put multiple views on the sheet, and you get that as indicated. You can change that text. So instead of saying as indicated, you can choose what it actually says. Unfortunately, we can't actually type any numbers, so we can't type a scale in there, so it has to be text. Whereas I was kind of hoping we might be able to fake it a little bit and put the right scale in that we want to see. But that's not quite possible yet. And something else there for detail views, when we're creating sections, doing call out views, and we reference another view. So, if it's a standard detail or something like that, then the reference label is now actually just an instance parameter. So we can change that on a view by view basis. And we can also add our own shared parameters into that, which again is just making it a lot more flexible for when we're documenting more complex projects here. And then probably the biggest one, and I think this is the one that most people, you know, regardless of whether you're MEP or structure or landscape or architecture, I think this is the one that's going to affect everybody the most, and probably, you know, save a lot more time. And this is really the idea that we can save the location of views on sheets and then apply it to other views so that they just all sit in the same place. So this is something I see time and time again. We've had guide grids, people adding in detail lines, the frustration of scrolling through a PDF and the building just sort of jiggles about as you go down each page because they're not perfectly aligned. And I've come across people that, you know, spend an awful long time getting those drawings lined up. So we'll jump into Revit and actually see this live now. So essentially inside of the Revit model, inside of a view, if I scroll down to the bottom of the properties, we've got an extra panel for the view, which is the view to sheet positioning. We've got some parameters there. So we have a saved position, and we also have the view anchor and the X and Y location of the view. The way we start using this is actually by going to the sheet and then placing that view on the sheet. So we drag it in and we have to position it in the way that we're all used to. And then once we've got it in there, if I look down at the properties, so I've still got the view selected, we can see now we've got the view position, so we can actually edit those coordinates, which I know that most people will probably want to do, just because we prefer to have whole numbers. And then once we're set with this, we can look at the ribbon up here. So the first one is the view anchor. So this, if you have a cropped view, whether that's with a crop region or a scope box, then we can set the anchor to be either of the corners, the center of the view, or we can leave it as the view origin. And the view origin is essentially the internal origin of the project. So on uncropped views, so therefore, you know, plans should align if we use the view origin, for example. But you know, we can choose any one of those. And then really we just need to save the position. So we click on, give it a name. So, and then we've got that position saved. So now come back to the other views. So these are all of the other levels of this building, and just multiple select down here, and in the bottom of the properties, we can assign that saved position in. Then we're able to go to the next sheet, and then we just drag this out now. We don't need to actually position it afterwards. It will just drop into the correct location, and we can continue to do that, knowing that all of these views are in the correct location. And we can actually select any one of these now, and we can come back and edit the position. So this way we can see where the view anchor is, we can see where the view is, and we can just drag it, move it. So if I put it right down in the bottom corner here and then just finish it, it'll let us know that the other three views will also be moved, so we can OK that. And then we can see that all of these views have now been repositioned into that same location. And if we started to place any of the others in, then they're going to drop into this new location as well. So that's kind of the idea behind it. Just seeing the question pop up as I'm looking. I do have a scope box here, but I have also done this without scope boxes. So without scope box, the view anchor itself would just be the view origin, which would be the internal origin of the model. Okay. I think where it's really going to come into its own is when you've got multiple views on sheets. So swapping across to this one just here, then if we're setting out sort of room drawings, room layouts, room data sheets, or if we've got multiple details or multiple sections and things in here, then what it basically means is we can assign a position into each one of these views. So we have the room plan, reflected ceiling plan, and then obviously for north, south, east and west elevations in here. We can then work our way through. So for all of the floor plans, it's quite quick then to just come and assign in the correct view location for those views, and the same with the ceilings. Obviously, it takes a little bit more time with the elevations because we need to work through all of the east ones and assign that, but you know, it doesn't take too long. And then once we have the sheet created for those, we can just go back to the View tab and then use the Place a View, and then they're named according to their room name. So if I just sort of search for the room name here, I can just grab all of the views for that room, and then when we say OK, they all just drop into the correct location. And that's kind of really, really good, actually, really, really quick to go through. So again, for this next one here, we can just search for that room. And that, you know, time-consuming bit of dragging the views out, place, it's kind of slow enough when you've got one view on the sheet, but when you've got half a dozen or so, then, you know, this makes it much, much quicker. Obviously, we still need to create all of the views and get them all cropped and things like that. So, you know, there's definitely tools that can help us do that. Some of our Navigate tools are really, really good at doing that. But yeah, the actual sort of tedious job of creating all of those sheets and placing all of the views on. And if we do need to edit one, again, we can just edit it on any sheet, and then it will update all of those to suit. So let's jump back to where we are. Actually, there's one more thing in here that I'll just mention, and this is based around the sheet collections, actually. So let's just make sure we're on the right one, which I think is this one here. Perfect. So looking down at the title block, we've got some sheet collections. So these were obviously introduced in 25. 26, we're able to add some extra parameters, some of our own custom parameters into the sheet collection here. So I've just added a work package and a work package code. And then any of the sheets that get placed within this collection will just automatically inherit these parameter values. So therefore, on a sheet view itself, we can kind of use any of that data, so we can see it's coming through into the properties of the sheet here, and therefore we can pick up on that in title blocks, and we can also pick up on that in things like drawing numbers. So if we're needing to use some of the ISO type numbering, then we can pick up on work package codes, and these are just automatically done as soon as we create a sheet in that collection, then that it gets that data. So again, nice and easy to use, and making it a little bit easier as we go through. So I think that's probably covering all of the points that we're going to go through. I think in general, you know, Revit evolves rather than being revolutionary. But actually, as you can see, there's quite a few tools in there which, as you say, may not be absolutely groundbreaking, but it's certainly going to speed up a lot of the sort of day-to-day time-consuming tasks like creating sheets, getting things in the right place and coordinated. And it's also worth noting that, you know, Lawrence mentioned about the IFC files, then they're also 50% quicker to load. When we're reloading linked models, that's also much, much quicker and with less sort of connected objects being disconnected, so that there should be less of those instances when lots of dimensions get deleted because we've reloaded a model and things like that. So I think overall there are quite a lot of general improvements, and it's a good sort of step forward. So any of the guys that were working on 23 or earlier, when you get to 26, it will feel like quite a step up. But as you go release by release, they feel like much smaller steps, I think, but they're definitely steps in the right direction. So with that, I think we'll hand back to Paola.
After having seen what Paul and Lawrence have shown you now, are you keen to update to the 2026 version after watching the news in this webinar? So we have a poll coming up in your screen now, and please submit your vote and let us know. So the votes are coming in. I'm not sure if you can see it, but at least I can see it and I can comment on it. So Paul and Lawrence, you did a great job. We have more than half of you are saying that you are keen to install the 2026 version. And about 25% of you, yes, but you still need more information. And that's, of course, okay. I have one final question for you, which is, if you do plan to update, when do you plan to update to the latest version? So, Anne-Marie, if you can help me with that. This is also a multiple choice. You can choose more than one answer. And please let us know. After almost 200 votes, about 1/3 of you want to wait for the first update of Revit. A lot of you also, 27-28%, when you start a new project. And that number keeps rising. 13% of you have already updated or are ready to update to 2026 already. So, with that in mind, we have a general recommendation for you. And this is our general advice. Wait for update 1. When a new version has arrived, there will be a few bugs which are being fixed in update 1. Update 1 comes normally late June. So our general advice is to wait for that and then start deploying Revit or the newest version of Revit in your office. Good thing is that about the same time, our Revit applications will also be ready for deployment. We will do a webinar in June. We have planned for it. We haven't set a date yet, but you will get some information on where to find it. So we will show you how to accelerate Revit even more by using Naviate in a webinar coming quite soon. Also, if this is valid for you, for those of you that doesn't have an IT department, this is a service that we can provide for you if you want to. So if that's the case, if you would like an IT expert from Symmetry, we can create the deployments for you, both for Revit and for Naviate, and we will do it when it's not that busy at the office in typically July and August. In addition to that, we will provide a What's New training, both for Revit and Naviate, probably mid-August. If this is interesting, please give a call or drop an email to your account manager at Symmetry. We hope to see you again on our next webinars. Please scan this QR code and you will be directed to the website where we have listed the upcoming webinars. As mentioned, the webinar on Naviate will be posted quite soon. The date will be late June. And with that, Lawrence, Paul, and I would like to thank you all for staying with us for this hour. We will publish the recording of this webinar to our YouTube page probably early next week, and you will all receive an email when that's done. Please share it if you found this presentation interesting. And we will continue to answer the questions that have been popping in. Paul and Lawrence are working hard to answer it all. From me to you, thank you all for joining us and have a great day.